Old used bike data overview presented by Shubham Sharma, Abhishek Reddy, Devatirtha Revati, and Abhinav Pandey. So the first slide is the data description. About this dataset, this provides a comprehensive collection of used bike listings across India. The dataset can also support insights into consumer trends, market dynamics, and brand performances in used two-wheeler segment. Coming on to the data overview, it has 1101 number of rows and the number of columns are six. The data attributes and usage. So there's company that identifies the brand of the bike, example Bajaj, Honda, or Royal Enfield. Name specifies the model of the bike within the company. Price is the expected price that specifies the model of the bike within a company. I sorry, but represents the asking price set by the seller. Location indicates the city or region where the bike is being sold. Distance traveled shows the total kilometers the bike has been ridden, and year refers to the manufacturing or purchase year of the bike. Coming on to the next slide, we have the dataset description, qualitative data, and quantitative data. In qualitative data, we have the nominal, which is the company, ordinal, which is the year, and text data, which is the name or the model. In quantitative data, we have continuous price, which is the expected price and the distance traveled. And if we take discrete, year could also be a discrete data if treated strictly as the whole calendar year. Next slide, we come to the old used bike dashboard dataset. In this, the insights which we can communicate, it is there is comparison which can be shown with the help of bar chart or column chart, composition which can be shown by pie chart, and so on. Next slide, we have the four charts. So the first chart is about the average price by company. So premium brands like BMW and Kawasaki command the highest resale prices. So brand positioning directly impacts resale price, and luxury and performance bikes retain higher value. The second chart tells us about the older bikes. It is about the average price by year. It is shown by a line chart. Older bikes from 1995 to 2010 show very less resale prices, and the insight from it can be drawn that newer bikes fetch significantly higher resale prices, indicating depreciation over time. The third chart is a donut chart, which is showing the count of name by company. So Bajaj, Royal Enfield, Honda, etc. These companies dominate the listings. The fourth chart is the average price by location. It is also a bar chart. So locations like Tumkur and Balangir show the highest average resale price. The insight can be drawn that regional variations exist. Some smaller regions list high value bikes, possibly due to limited availability. Coming on to the next slide, we have the other three charts. So the fifth chart is about the count of name by location and company. This is a stacked bar chart. So cities like Bangalore, Hyderabad, Chennai, Pune, etc. dominate the number of listings. Insights can be drawn that urban centers drive the used bike market, reflecting higher mobility and demand. The sixth chart is also a donut chart, which is about average distance traveled by a company and name. Some commuter bikes like Hero show high average kilometers, reflecting long daily usage. And the insight drawn is usage patterns differ. Commuter bikes are heavily used, while premium bikes are sold earlier with lower mileage. The last chart is also a donut chart, which shows the different view. It shows the average price by company, confirms earlier findings that BMW, Benelli, and Kawasaki command the top average prices. And the insights are that clear divide between premium and commuter brands is in resale value.
Hello everyone. I'll explain the descriptive statistics I worked on for our project focusing on travel distance and price. For this dataset, I calculated key statistical measures such as the mean, standard deviation, minimum, maximum, median, mode, skewness, kurtosis, and range for both travel price and travel distance and price. These measures helped us understand better the overall distribution and pattern in the data. So, uh, Next, I have prepared the insights from descriptive statistics. For travel distance, the average distance traveled is about 31,300 units, while the median is 23,500, indicating a right skewed distribution. The mode is 30,000 units, meaning many customers traveled similar distances. The standard deviation is very high at 1,18,835 with a range of about 3.89 million units, showing significantly variability and outliers. For price, the average price is 89,763 units with a median of 68,000 units, again showing a right skewed pattern. The mode is 45,000 units, so many items are priced lower. The standard deviation is 67,859 and the range is 4,42,000, indicating moderate variability. The skewness and kurtosis suggest some outliers and not as extreme as travel distances. The data shows that both travel distances and prices are right skewed with more extreme outliers in travel distance. These insights help us understand customer behavior and price distribution better. Thank you.
Uh, So here I have applied a two sample t-test, assuming equal variance to compare the mean of travel and price. The null hypothesis is that the mean difference between the two variables is equal to 22,324.04. And the alternative hypothesis is that the mean difference is not equal to the hypothesis value. Now, looking at the result, the calculated t statistic is minus 19.58, while the critical t value at a 5% significance level is only about plus or minus 1.96. Since the absolute value of t statistic is far greater than the critical value, this already suggests strong evidence against the null hypothesis. Secondly, the p value is extremely close to the zero, which is much less than the 0.05. This further confirms that the probability of observing such a result under the null hypothesis is almost impossible. Based on both the t statistic and the p-value, we can confidently reject the null hypothesis. Therefore, we conclude that the mean difference between traveled and the price is statistically significant and is not equal to the hypothesis difference of 20,324.04. In simple words, there is a strong and a clear difference between the two variables that cannot be explained by chance. Thank you. Now moving to the next slide. Vishik, please speak the conclusion.
Vishek, give the conclusion.
Critical.
Abhishek. Yes, yes. Next slide, next slide.
Thank you.